So we start in section 3.1 with the introduction to quadratics. So I'm going to make a separate video on a bunch of factoring stuff, but we're going to start with, there are three forms of a quadratic. So standard form, the y equals ax squared plus bx plus c. Vertex form is y equals a times x minus h squared plus k, and factored form is y equals a times x minus r times x minus s. We're going to start today in particular with the standard form, and in all of our forms we're going to be interested in, for their graphs, we want to know the shape. Does the parabola open up or down? Is it going to be wider or narrower than y equals x squared? And we can tell in all these cases the a that you see here is the same, and hopefully you remember from your Algebra 2 days, if a is positive, the parabola will open up, and if it's negative, it's going to open down. If that a is bigger than 1, it's going to be narrower or skinnier than a y equals x squared parabola, and if it's smaller than 1, it'll be flatter or fatter or wider. So that's the shape part. We're going to talk about a vertex shortly. We're going to have two different methods. I'm going to talk about method number 1 today, shortly, and then we'll talk about method number 2 a little bit later. And as we go and graph these, we'll talk about what we mean by the axis of symmetry. The X Intercept and the vertex can provide most of the challenge for us here. And then the y-intercept is not too bad to find, and if we know the y-intercept, what we're going to call the symmetric point is that point on the other side of the axis of symmetry from it. We'll talk about that in a little bit. So let's first talk about our method 1 for finding the vertex of parabola. So I'm going to say find the vertex. So I'm going to tell you what it is, and I'm going to give you a little bit of a justification for that. The x-coordinate of the vertex of a parabola, if you can remember it, is x equals negative b over 2a. That's when our parabola is given in standard form. When we have y equals ax squared plus bx plus c, the b is that coefficient of x, and the a is the coefficient of x squared. The x-coordinate of the vertex is going to be that negative b over 2a, and then you'll find the y-coordinate just by plugging that into our function. Now, some people struggle to remember this, but if you remember the quadratic formula, I'm going to try to give you a justification or a way maybe of remembering this, because hopefully we know the quadratic formula. If not, this is a must-know, that x is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And some of you can sing it or hum it if you like, if that's how you learned it. So the idea is, okay, I'm back. I hit a button by accident. So here is the thinking on this. If we separate this out, see, I'm a left-handed, and when I touch the screen in a bad place, it does weird things. So you can think of this as being negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So you can separate out that fraction. So my claim is that whatever this number is, our two X intercepts, this is going to be where our parabola crosses the x-axis, it's going to be this distance added to negative b over 2a, and this distance subtracted from negative b over 2a. So if this is wherever our negative b over 2a is, then our x-intercepts are going to be this distance to the right when we add the square root of b squared minus 4ac all over 2a, and whatever that distance is to the left. The point being that the middle, or the center of that parabola, is going to be at x equals negative b over 2a. Since our parabola is going to have to either open up or open down as it goes through those 2 points, the vertex is going to have to lie on this line x equals negative b over 2a, which means its x-coordinate is going to be there. So, long story short, the x equals negative b over 2a is going to be that very beginning part of your quadratic formula. So I'm going to go to a new screen, and we're going to graph one here, and we're going to find all of these things, and we're going to find our vertex using x equals negative b over 2a. Okay, here is our parabola. We're going to graph y equals x squared for this one, minus 2x minus 8. And we are going to find the vertex. We'll do this on all of our parabolas. We're going to find the X intercepts. These can be challenging. That's the vertex and the X intercepts are going to usually be the hardest things to find. We're going to find the Y intercept, what we're going to call the symmetric point. I'll tell you what we mean by that. And we are going to put in the axis of symmetry and label it. Okay, so I'm going to put our XY axis over here, and let's see what we can do. So to find the vertex, what we're going to do first is we're going to plug in negative b over 2a. That's going to be the x coordinate of our vertex. So the b is negative 2, so negative b is going to be positive 2. A is 1, so 2 times a is 2 times 1 is 2. So the x coordinate of the vertex is going to be 1. To get the y coordinate, we'll just plug the 1 into our parabola in place of x. So we're going to get 1 squared minus 2 times 1 minus 8. So that's 1 minus 2 minus 8, I think is a negative 9. So we're going to get the vertex to be 1, negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to put us right there. I'm going to label that 1, negative 9 as the vertex. Now the x-intercepts, what we're going to do there is we are going to always take our parabola and set it equal to 0 and solve. Now in a good situation, when this behaves nicely, we'll be able to factor that using your box and diamond or whatever method you have learned. When it doesn't factor nicely, then we're going to be stuck using the quadratic formula, and we'll see an example of that one in the next one. This one, however, factors very nicely, and we're going to make sure we have to be good at factoring. So if you are a little rusty, you're going to need to brush up on that. So we're going to get x is 4 and x is negative 2. So that's going to make our x-intercepts, remember they're ordered pairs, 4, 0 and negative 2, 0. So there are the x-intercepts. This is our answer to B, and this was our answer here to A. So we're going to plot those points. We have negative 2, 0. That's going to go right there. And 4, 0, 1, 2, 3, 4, 0 is going to be right there. Then we can find the y-intercept. So the y-intercept is pretty generally easy to find. You're just going to plug in 0 for y, or for x rather, and when you plug in 0 for x, we can see we're going to get on negative 8. So this was negative 9 down here. That's going to make 0, negative 8 our y-intercept. Now what I mean here by the symmetric point is I'm going to put in here the axis of symmetry. So the axis of symmetry is that vertical line that goes through the vertex, and so it is the line that kind of splits our parabola in half. If we reflect it in that line, it lands on itself. So what we mean by the symmetric point is that point on the other side of the vertex from the y-intercept. So the y-intercept is over here at 0, the vertex is 1, so on the other side of that, and at the same y value, is going to be 2, negative 8. That's what we are going to call the symmetric point. And so then, after we do all of this, The hope is, and the axis is symmetry, I'm sorry. That's that vertical line. Now remember, a line needs an equation. So it has an x value of 2. It is the vertical line, an x value of 1. It is the vertical line x equals 1. So don't just say 1 because that won't get full credit. It is an equation of a line x equals 1. And then what we get is going to be our parabola. So it's going to contain all 5 of those points. So it's going to do something like that. So this is what we're going to do when we graph our parabolas. And we'll do this eventually in all 3 of the forms that we have seen. But today we're just going to get ones that are in standard form, y equals ax squared plus bx plus c. And we're also going to learn a second way of finding the vertex. But today we'll just use negative b over 2a. I'm going to do another screen and we'll do another example. So we're going to graph and do all of those things that we did before. And this time we're going to get y equals negative 1/2 x squared plus x plus 1. So we're going to find the vertex first. And if you remember, we're going to use x equals negative b over 2a. So negative b is going to be a negative 1. 2 times negative 1/2 is also negative 1. And so our vertex has x-coordinate positive 1. To find the y-coordinate, we're going to plug in 1. So we're going to have negative 1/2 plus 1 plus 1. Negative 1/2 plus 1 is positive 1/2. Plus another 1 is 1.5 or 3/2, whichever way you like. So I'm going to build this as we go. Here is our xy axis, and the vertex we now know is going to be at 1, and it's going to be 1.5. Whoops, let me see if I can fix that. So there's 1, 2, so our vertex is going to be 1, 1.5 is going to be right here. Now we know that this parabola is going to open down, and it's going to be a little bit wider because of the 1/2 being less than 1. So there's our first point. So maybe let's do the low-hanging fruit. Let's find the y-intercept next. So the y-intercept, we can just plug in 0 for x, and that's going to give us 0, 1. So that's going to be this point right here. That's consistent with this being a parabola that opens down. Let's kind of build on this and get our symmetric point that comes hand in hand with our y-intercept. So we can see that on the other side of the vertex from the y-intercept is going to have to be another point there. And that's what we're calling the symmetric point. And so it's going to have coordinates 2, 1. Then we're going to find the x-intercepts. So this could be a little bit messy. Let's see, we're going to put in 0, and we've got negative 1/2 x squared plus x plus 1. If we want, we can multiply through by negative 2 and get rid of the fractions and make the leading coefficient positive. That's going to be x squared minus 2x minus 2. This has the same solutions, the same thing, values of x will make it equal to 0. Sadly, this is not going to factor. So now we are going to use the quadratic formula. I'm just going to remind you one more time. And it's negative b plus or minus the square root of b squared minus 4ac all over 2a. You definitely have to know this from memory. And so that's going to be, let's see, b is negative 2, so negative b will be positive 2, plus or minus the square root of b squared is 4, minus 4 times a is 1, and c is negative 2, and that's all over 2 times a. So we're looking at that. So we've got 2 plus or minus. See, the 2 negatives are going to make it a positive. 4 times 2 is 8. 4 plus 8 is 12. So we're looking at 2 plus or minus the square root of 12 over 2. Now 12 we can simplify. We can break that down. 12 is 4 times 3. And so we can make that into the square root of 4 times square root of 3. Since the square root of 4 is 2, that's going to become 2 plus or minus 2 square root of 3 over 2. We can simplify further if we separate that into 2 fractions. the 2 over 2 plus or minus the 2 square root of 3 over 2. Now we can see that we can cancel these and cancel those. And so that's going to leave us with 1 plus or minus the square root of 3. Whew. Now we got to figure out where to place that. Well, I'm going to go back for a moment. Let's see. We have, this could be a challenge. So I'm going to look at this part right here and see if we can figure out what that is. So 2 plus or minus, now the square root of 12, the square root of 9 is 3, and the square root of 16 is 4. So this is going to be like, this is just a rough approximation. It's in between 3 and 4. So if we took 3 plus something a little bit bigger than 3, so 5 plus, and divided that by 2, so 5, roughly 5.5, divided by 2, that would be a little bit less than 3. So I'm going to plot this, one of the X intercepts is going to be that 1, oh, I'm doing it the hard way. There's an easier way. Let's come back and look at this. This is much better. So here, square root of 3 is a little bit less than square root of 4. So 1 plus something a little bit less than 2 is going to be a little less than 3. So we're in the right place, but I was thinking of that and making it harder than it had to have been. So there are the coordinates of that x-intercept. Now the 1 minus square root of 3, since square root of 3 is a little bit less than 2, is going to be something that's in between 0 and -1. So I want to place it in the correct location, and I'm going to label it exactly. So this is what we're going to do. You're not going to be able to use a calculator here, so you're going to have to figure out how to estimate these things without using your calculator. So let's find the axis of symmetry. And so our axis of symmetry is going to be that vertical line that goes through the vertex. And remember, we have to label this. It's an equation, so it needs an equal sign. And so once again, we're going to get x equals 1. And then I'm going to connect all 5 of those points, and that is going to be our parabola. Okay, so that's it for this part of the quadratics, the graphing part so far. I'm going to make a companion video here and go through a bunch of graphing, solving equations by factoring and using the quadratic formula.